Hello, everyone, and welcome back to this part two on the Docker webinar series. In part one, we covered the concepts of Docker and how we can apply Docker and container technologies to the development phase of software development. This phase, or in this section, we're going to talk about production deployments, which I think is the hottest topic in the industry right now and probably the most relevant to many of you here. So in order to make this session valuable to you, let's kickstart this session off with a poll to better suit, help me get an idea for what I can talk about in this session. So thank you for filling out that poll. I see that most of you have actually never used Docker before, and only a smaller percentage of you are actually using it in production right now. So I think what I will do is slightly adjust the content for the webinar to hit the larger audience. So my goal here is to familiarize you with your production deployment options. I'm going to do a short presentation and a demo. And we'll do 15 or 10 minutes for Q&A, so please put your questions in the chat. And given that most of you have never used Docker before, I think I will take questions related to how we can do Docker in production, maybe even run the concepts. And also, just so everybody knows, if you submit a question and it's not answered here, I will do a complete follow-up Q&A on the Cloud Academy forum. So if you don't see your question answered here, check back to the Cloud Academy forum for detailed answers to all of the questions, even the follow-ups for ones I will answer during the session. So in case you don't know me, my name is Adam Hawkins. I run the Site Reliability Engineering team at SaltSide. We have roughly 350 containers right now in production. We've been using Docker in production for just over 2 years. I've also created the Introduction to Docker course on Cloud Academy. You can find me on Twitter at admin65, and you can also check my blog for lots more information on Docker and infrastructure engineering and continuous deployment. So we're talking about deploying Docker, and the sort of TLDR here is that really it's all about orchestration, but there's many different sizes for applications. When we talk about microservice, service-oriented architecture, maybe even monoliths. So the thing to take away here is that there's different deployment strategies that make sense for the size of your application. And the question you need to start asking is actually, how big is your application? Is this a distributed system with, say, multiple different services, hundreds of containers, or am I looking at, say, a monolith where maybe I have, say, just one web server, maybe not even like a very big monolith, but just I have one process, or maybe I have a web server, a job queue, a DB, or I have a very large distributed system. And the answers to these questions are going to influence how we actually go about creating our deployment strategy. So in this session, we're going to talk about a few things. First, golden images, also using Heroku for Docker, Docker Cloud, Docker Swarm, also Docker Data Center, also known as UCP, ECS, this is the Amazon offering, Kubernetes, and also the hosted version of Google Container Engine, and finally Mesos and DCS. So what I'm going to do is go through each of these options. I mean, this is just a small subset. There's many, many possible options, but what I'm going to do is go through and give you some pros and cons of each of these different methods to help you decide which one may or may not fit for your organization or team based off of what kind of requirements you have. So let's start off with golden images. So golden images, maybe you're familiar with this concept already, but what you do is fully bake an image. This could be an image for VirtualBox or VMware or even AMI for Amazon, or an image for Google Compute Platform, or even for Azure. And you can have that run an appropriate Docker image. So you have a fully baked image ready to deploy to whatever infrastructure you're using. So one pro here, like many of the things that we're going to see, is that this supports cloud and on-prem infrastructures. I know that many people are working in businesses where they need to have, physical control over the machines that are running their application, and this can be used if you're using, bare metal with VMs or, cloud providers. So this is also very easy to start with, and one of the reasons why I like this approach is it scales up nicely for different, for disconnected services and people who are maybe deploying 1, 2, 3, 4, 5, 6, different applications. Actually, in the past, we used this approach at my full-time job to deploy, I think, up to 6 different unique applications. So one of the reasons why I like this one is it's very easy to scale horizontally and vertically. Given that we're using a fully baked image, for a VM or an AMI, it's easy to say, all right, give more memory to the VM, or I want to use a larger instance type on EC2. And given that everything's fully baked into the image, we're dealing with basically stateless machines. So it's very easy to say scale horizontally by adding or decreasing the number of machines that we need based off the load that we see. But unfortunately, this requires you to actually have a good amount of infrastructure engineering experience. So you need some tools to actually bake these images, like Packer or something like that. Maybe you're going to coordinate the actual deployment process with something like Terraform or CloudFormation, but it requires you to have the skills to actually build the infrastructure and the pipelines to put these things in motion. Now, this can be a fast or slow process, but generally it's going to take at least a couple minutes to build the next version of your image, depending on what sort of happens. But it's going to probably be slower than some other processes. So moving on, we have Heroku, and I hope that many of you have heard of Heroku, maybe even used it, but Heroku is really a full-featured platform as a service. It gives everything, all of the features and things like that that a developer or engineer might need to actually put an application in production, manage it, scale it, without needing much operational experience. So the biggest pro here is that you have a well-established feature set with many integrations. And Heroku has been around for years, very well-established player and very polished UX and feature set. Now, they also have database as a service. So if you deploy your application on Heroku, you can connect up to Heroku Postgres or integrate with some of the third-party providers for MongoDB or Redis or any of the other things that you need. Odds are you can just pay a little bit of money and get them connected to your application. But unfortunately, Heroku is a bit expensive, but you have to decide if this cost trade-off is actually worth it for you, because you get a lot and you don't have to manage it, but it can be pricey compared to some of the other options. Coming back again to some of the ease of use factors, you have a lot of stuff baked into the product itself, so you can easily access your logs, manage your environment variables. So you can have, say, one command like Heroku logs just to tail all the logs to your application. Same thing for environment variables. Now, given that containerized applications practice the 12-factor application strategy, environment variables are key. So having ways to to easily manipulate the configuration goes a long way. So you have easy access to horizontal and vertical scaling. Heroku gives you two different sizes of containers. You have what they call a 1x and a 2x, which is basically, say, more CPU or RAM, and you can easily scale up the number of processes or scale down the number of processes with a simple command. But depending on where your application needs to be hosted or where your users are, you may need to, say, be in a different region. I think Heroku right now has support for US regions and EU and European regions, but if you're in Asia, this might be something you need to consider. One thing that's actually really nice about Heroku is you can connect it to GitHub automatically. So once you do a push to GitHub, Heroku, this can automatically be set up, so every push is just deployed. So you're basically just 1 or 2 clicks away from having automatic continuous deployment, which is, a real step forward compared to some of the other methods. And next up is Docker Cloud. So Docker Cloud is a kind of a curious case in terms of product offerings, but you provide, I have a typo on my slide, but you provide the compute and Docker provides the orchestration. So what happens is you provide the infrastructure, be it a physical machine on-prem or a cloud instance, and you install their agent, it connects up to Docker Cloud, and then the agent sort of handles the rest. So one nice thing here is this is a first-party offering, and what Docker is trying to do is be a bit more, say, integrated across the whole tech stack. So this can be a pro and a con. So you, of course, have to provide your own compute, but you also have to provide your own compute because it's not fully a hosted service, right? You have to provide this infrastructure, and say if you're running on EC2, if those instances go away or some maintenance or whatever, they're not going to be automatically recovered. So it's a pro and a con. They also offer one-click integration for CI, for continuous deployment. So this is a nice option if you're maybe looking at, say, a small application or just want to kind of get a feel for how some deployments would actually work with a low-touch offering. I consider this a con because you end up actually have to pay double. First, you have to pay for the Docker Cloud service, and you have to pay the charges for the infrastructure that you run. So let's move on to some of the other first-party offerings. So Docker Swarm. So this is where we start to get into the bigger orchestration tools, more focused around larger applications, more and more moving components, more containers, more intercommunication between containers, and these applications tend to have different sorts of requirements. So this is a first-party cluster orchestration. So I know that based off the poll, most of you haven't used Docker before. So when we talk about orchestration, what we're talking about is the means to sort of coordinate individual tasks or containers across a cluster of compute resources. And these compute resources may be running on the physical hardware, or even in one cloud provider, even multiple cloud providers. But the high-level idea is you're going to tell something to say, I want to run a container or some task, and that thing is going to figure out where it should actually run based off of what the requirements are. So you can specify things like CPU and memory, and it will find, say, a slot on that cluster to run your particular container. So Docker is putting a real, some serious effort into their first-party offerings like Docker Swarm. So there will be a lot of bug fixes, a lot of energy and manpower going into improving this as a product. So pro, you provide the compute. So if you need to run this on-prem, you can. If you want to run this on, one cloud provider, you can. So for me, Docker Swarm is kind of a hit or miss because it's brand new. I mean, it's not necessarily brand new, but it went through a big revision in the latest version of Docker, and it's slightly untested compared to some of the other more tried and true production options that we have. Now, one big benefit here compared to some of the other options we discussed so far is that this supports native Docker client operations. So for example, if you're using something like Heroku, you can't just say Docker build because there's no Docker daemon on the other side. Whereas if you have a Docker Swarm, you can point your Docker client to that. So all of the workflows that you're using around, say, Docker Compose or Docker itself will work natively against a Docker Swarm. Oh, I got a double pro. Oops. So moving on to Docker Data Center. So Docker Data Center is another first-party offering, and what Docker Data Center is a combination of a few different Docker products. So Docker Data Center is a combination of Docker Swarm and Docker Trusted Registry with a UI on top for managing user authentication access. You can hook up your LDAP server, things like that, so you can grant your employees or team members access to the cluster, and then users can have different level of access. You can say these groups of users can manipulate these containers, and you can create these sort of things. So it's really a combination. Docker Data Center is mainly aimed at, quote, enterprise or larger businesses. The UCP is short for Universal Control Plane, which is their sort of a UI or bootstrap or like sort of their admin panel around all of these different products. So the pro is that you pretty much get an entire functioning full Docker stack right out of the box. So you don't need to worry about, you can say have your own private registry, all of this stuff. And it gives you Docker Swarm out of the box. So it's kind of a combination of the last thing that we talked about. So a con that I've noticed is it actually lags behind the Docker daemon. The Docker project is moving very quickly. I mean, very, very quickly. And there's a lot of things happening in the new version of Docker. And given that UCP is a bit older, some of the new features in Docker are not supported directly in UCP. For example, the newest version of Docker Swarm in Docker 1.12 is not used in Docker Data Center. So that will eventually be addressed. Also, based off of my testing, the 1.x branch has issues with multiple availability zones. So if you're trying to create a highly available infrastructure, say running in multiple availability zones, you may hit problems here. And the Docker team is aware of this and has planned fixes for version 2. So something to keep a lookout for until version 2 comes along. So another pro and kind of a con is that you get to decide where you actually want to run this. Docker actually does provide, say, what they call the Docker Quick Start, which is a CloudFormation template for AWS, so you can do, a few clicks to build the stack if you want to test it. One big con here, though, is that this is actually pretty expensive. So this is $150 a month per node. So if you have 10 machines, well, you can do the math. So this is going to add up. And depending on the workload, you have to pay this on top of whatever infrastructure cost you already have. So it's something to keep in mind. Next up is the AWS Elastic Container Service, or ECS for short. So if you Google ECS, you'll find plenty of information about this. It's most commonly known as ECS. So what this is kind of like it's a middle ground between larger orchestration tools and like a kind of first-party offering by AWS. And really what it does is you install an agent on your EC2 instances, and then you can use this ECS API to schedule tasks or schedule containers. So the pro here is that it runs on AWS. If you've already used AWS, you're kind of ready to make a potential jump onto ECS. But it's not necessarily an entirely managed thing. It's quite complicated to set up, actually. So once you have to do all of the work to provision your instances. Now, if you're trying to create a production infrastructure, say high reliability, you have to automate that part and put all that effort in there, and then also do the thing on top to install the agent and do the configuration. And like most AWS products, it's not really intended to be consumed directly, but more as a lower level for other people to build on. So you might find it a bit rough going in the beginning, but Luckily, there are higher level tools built on top of these APIs that provide a bit a nicer UX, kind of what you would see with something like Heroku or something else. So moving on, we come to some of the real heavy hitters in the orchestration and current container production space. So here we have Kubernetes, which is containers as a service. This is a Google-backed project, which is a production-ready orchestration system. So what this is this really works for all sizes of applications, but you may not get the same benefit if you had, say, 2 containers versus if you're dealing with 200 containers. It's really kind of aimed for larger scale applications. So pro here is that you can run, you get to run this on your own infrastructure. The Kubernetes project has a bunch of scripts to bootstrap a whole working cluster, which is no trivial task because you have masters, you have replicas, you have complex infrastructure that you need to manage for the high reliability aspect. So you can run this yourself. You can choose, where you want to run it, be it on-prem or in, what geographical regions, anything like that. And if you want to use Kubernetes but don't really want to deal with the overhead or don't have the capacity or the skills to manage a complex distributed application, Google actually has a one-click cloud offering they call Google Container Engine, which is basically host Kubernetes. So you just say, I want a Kubernetes cluster, I want this amount of compute, and you click provision, and then you're good to go. Now, this also requires you to learn an entirely new system. Each of these different deployment methods or task schedulers, whatever, has a similar model, but it's also different enough that it requires you to really sit down and take the time to go through and learn all the different decisions, the different vocabulary, the different things involved with actually coordinating larger applications. So if you're just looking for something where you can just say run Docker, Docker run, Kubernetes is not going to give that to you. This is what I talk about when I mean does not support Docker clients. It's not a Docker daemon. What it really is a way to schedule containers, and that requires, and actually Kubernetes supports other container engines than just Docker. So one con here is that this is really for container native applications. So Kubernetes is really kind of a containers as a service type thing. So what it expects is that everything that's going to run on there needs to be containerized. So this could be a con for you if you have things that are not containerized. However, this might be a pro if you're used to dealing with a containerized world, because some of the abstractions and the model in Kubernetes fits quite nicely if you've been working with containers. So Kubernetes is actually a really powerful base to build even more complex orchestration or production deployment system on top of. OpenShift is actually built on top of Kubernetes and does all of its things, like deploy some built-in applications and things like that on Kubernetes. So if you're looking at, say, a low-level thing to potentially build a much larger or, say, use case specific solution on, Kubernetes could be a thing for you. One of the reasons why I also like Kubernetes, it gives you a simple deploy strategy. So you can do easy horizontal and vertical scaling with Kubernetes. You can say, I want this container and I'm running, and I want 5 of this and 3 of this. And when you do a deploy, it can do a rolling deploy. So we'll update 1, and then 2, and then 3, and then 4, and then 5, and so on. And you can control, say, how many it does at once, and these sort of things. So it gives you just a little bit of that deploy strategy. Now let's move on to the next one, which is Mesos and DCS. So what Mesos is, or Mesos as some people call it, is what, in their own words, is a distributed systems kernel. And what they mean here is that they're kind of like an operating system for your data center. And actually that's what DCOS stands for, is Data Center Operating System. So Mesos can really do it all. It powers Twitter, it powers a bunch of companies with big, complex systems. So pro here is that this works for all sizes of applications. And the same thing with Kubernetes is that, yes, it works with all sizes of applications, but you really don't see, you get much more benefit the larger and more complex your workloads become, because that's really what it's intended for. So if you just have one container, probably not worth it for you to make the jump into this sort of deployment architecture. So again, here you can run this on your own infrastructure, and if that's not your bag, Azure actually has a one-click hosted offering. I've not used it, but I was quite surprised and happy to see that you can get a hosted solution from a cloud provider. So again, this requires learning an entirely new system and an entirely new set of abstractions and thinking, and these things are not, it's not a trivial pool to jump into. So with Mesos and DCS, you're going to do stuff of, okay, Mesos is actually just a low-level thing. It doesn't necessarily give you so much, but it's not until you add the frameworks on top of that for, say, Chronos for cron-type things, Marathon for long-running things, with all those other frameworks. It gives you a bit of mix and match capability, but you have to be careful what you choose. But if that's a bit too much for you, you can go with DCOS, which is actually built on top of Mesos, which kind of gives you an integrated package right out of the box. So if you've never heard of Mesos or DCOS, I suggest you check out some of the demos of this thing. And I mean, for me, it really blew my mind, but it gives you an idea of what's going on and where the production and deployment area is heading. And again, another con here is that this does not actually support Docker clients. This is not a Docker, this is not a Docker daemon. So you cannot just pull your Docker client to it. It's an entirely different sort of thing. So one pro here is that this is actually for containers and non-containerized applications. I mean, Mesos is really powerful. So you can run containers, you can run non-container applications, you can run like stateful applications. You have functionality to support many different types of workloads. And it's also available in paid and open source offerings. So if you are in a situation where you like to have a bit more, say, formal support from the team or other features, you can get that through the paid or professional offerings. Now, one of the reasons why I really like Mesos is that through their frameworks, they give you multiple deployment strategies, and this is where that starts to become really powerful. With Kubernetes, we talked about how they have rolling deploys, but you can get some frameworks from Mesos that give you much more interesting and useful deploy strategies. Things like canary deploys. You can automatically set that up, and the framework can handle all of the aspects of deploying your application with those things in mind. So it's real powerful stuff. Now, my goal for this scenario is to, or not this scenario, but my goal for this session is to give you some information to help you make an appropriate decision. So here are my recommendations for you based off of your application and some of your requirements. And after we talk about the recommendations, we're going to go into a short demo of creating your first pod and deploying an application on Kubernetes. So if you're just getting started, I find that Heroku is seriously great for small and non-distributed applications. So if you have, just say, a monolith, all right, you have your web server and the database. There's no need to go into a more complex infrastructure. Plus, Heroku is going to give you everything that you need, the logs, environment variables, scaling, the integrations. And usually if you're dealing with this smaller or non-distributed applications, you usually have a small engineering team also. So Heroku can solve a lot of problems. And given now that they have actual Docker support in their Docker build pack, it can be a seamless transition if you've already used Heroku or already maybe have a containerized application. So as we start to move a bit forward into the scale of our technical requirements, we talk about more applications, maybe say more containers, more interdependence, or more communication between the containers or the different parts of the application themselves. We start to move up into more infrastructure requirements. This is maybe where you start to need to run your infrastructure where you want to. So I recommend golden images for people who are sort of moving off Heroku or moving out of the scale and want something they have a bit more control of, but don't necessarily want to move to something that requires so much more effort or change in thinking. There's plenty of great articles on how to do golden images out there and how to deploy them, so I recommend that you check that out. Or if you're not too keen on golden images, you can take ECS, or more importantly, something kind of built on top of these primitives like Empire or Convox to give you a more sort of Heroku-ish feel in terms of functionality, but a little bit more control over the infrastructure or how your applications are running. Now, if once you kind of get past this, you hit the scale where, okay, now I have, say, hundreds of containers or a much larger scale, then I recommend Kubernetes for you, especially if you have a container-native application. Like if you've been practicing, say, I'm not sure if this is a term, but container-driven development, where you're using containers all throughout your whole development process, it's a real trivial leap to make a jump to then deploying to something like Kubernetes. And especially now, if you don't want to actually host or manage a cluster yourself, the one-click offering through Google Container Engine is really tough to beat. Right now, I think that using Google Container Engine is the easiest way to have a production-ready container infrastructure, bar none, that actually scales up in use also. Now, if you're even bigger, if you're thinking even larger about, say, how can I support my entire organization or my entire team, then probably something like Mesos or DCS makes a bit more sense for this use case. So consider that maybe you have containerized applications and non-containerized workloads, maybe even things like databases or Spark or Storm or things like that. Then Mesos or DCOS can really make a big difference for maybe your ops team, or for your organization in general. Because at that point, then they don't need to build unique deployment infrastructure. They can write the Mesos config files, deploy the things, regardless of what the actual task is. So this wraps up the recommendation section. And if you have any questions on why I made these recommendations, or if you have a different use case in mind or some different technical requirements, please put your questions in the chat so we can come back to them. Now we're going to move on to a short demo. I've now been talking for about 30 minutes or so. So I want to go through writing a simple pod in Kubernetes to give you a feel for what this feels like in the real world. And we're going to actually expose those pods so we can interact with them outside of the cluster. And I'm going to explain these terms as we go along. So I'm going to close this presentation and move over to my terminal. If you can't see the text, let me know and I can increase the font size, but I think it's okay where we are. So I have a simple Docker Compose, or not necessarily Docker Compose, but a multi-container application. Let me show it to you. Let me go into my virtual machine where I have my Docker daemon running. So what I have here is I have a application that contains 3 different containers. I have a HTTP API that accepts a POST request to increment a counter and a GET request to retrieve the counter. The counter is actually stored in Redis, and then I have one container that is using the API to continually print out the counter, and another container that's running that randomly increments the counter for a given So what I want to do now is just quickly boot this application so you can see how this behaves. So let me go to part 2. Let's run Docker Compose up. So I have my containers running. You can see here I have my server just running node, a Redis container, and my counter is printing the value, and the counter is incrementing, and the poller is printing out the value. So this is a kind of contrived example of what you can do with microservices. So if you attended part 1, you came to know about Docker Compose. So in Docker Compose, we have the server, some environment variables, a counter, and also the poller. So now what we can do is create a Kubernetes pod from this. And I actually have Minikube installed on my machine. Let me just start my cluster here. So Minikube is a Kubernetes cluster running in a local VM. So you can install this with Homebrew or probably through your package manager on Linux if you're curious, and get a local environment to play around with. Let's just let this boot up, and now I will pull open my pod file. So here I have a file that describes my pod. In Kubernetes, the pod refers to a group of containers who function together, who are interdependent, usually communicate together. So what I have described here is a pod that contains 4 different containers. Now here we can run any types of images we want. Right now we're just using only public images on the Docker registry. And here I have my name Redis, and I can also map the container ports for inter-container communication, either between this group of containers or expose this throughout the wider cluster. Now here I have my server container. This is in the image that I had built previously that I showed by doing a Docker Compose demonstration. And here we say this container runs on port 8080. Now you can also customize the environment variables. So given that we use the 12-factor application practices, the applications are configured through environment variables. So here I set an environment variable called Redis URL, and then set the value to Redis, and then set the host to localhost in 6379. So inter-container or inter-pod communication works by using localhost. All containers in a pod can talk to the other containers in the pod by using their declared port. So here, 6379, and the host, localhost. So down here we have the counter container. This is the one that's talking to the API and making a post request to increment the counter. So here we set the API URL to HTTP localhost 8080, where 8080 is the port for this container, and the same thing here for the poller. So now that my kube cluster is running, we can interact with it. So quickly I'll just give you a taste of this. So I can say kubectl get pods. This will tell me everything that I have deployed right now. It doesn't return anything because I don't have any pods deployed. So now what I can do is create my pod. And it says pod demo created. Now this process is asynchronous. So what you want to do is then kubectl describe pod demo. And this will show you everything that's going on. Let me just scroll through this quickly. So you can see information about the containers, and you can see the status of everything. So what this is telling me is if I were to do get pods again, I can see that, okay, name demo, and I have 4 out of 4 containers, and they're all running. So now I can actually get the logs for these containers, So I can say polar, for example, and I can see what's outputted. I can also do, say, -F for follow, and I can stream these logs in real time. Unfortunately, the kubectl command does not give you a way to get all of the logs for all the containers at once, so you have to go through them individually. So we could also look through the counter and follow those logs. And off we go. Right, so now that we have these containers running, we want to be able to interact with them from outside. It's clear that these containers can talk to each other, but how can we actually expose the functionality of our application out to, say, the wider internet? And we do this through what's called a Kubernetes service. And where Kubernetes really starts to shine is that it can configure like internal load balancers, external load balancers, things like that. So if you're on AWS, you can say, take a pod, and it will automatically create an ELB. If you're on Google Compute Cloud, or Compute Platform, it can create a load balancer there also. So what we have here is the definition of a service. So this service is going to say, find all of the containers matching these labels. So here we have pod, and the pod file, and here we say labels app demo. So services may not necessarily be tied to, say, one particular pod. As long as the things match the selector, we can expose them. So then what I do is create this list of all the ports that should be exposed in this service. So name server, port 9292. This is a port that would be available to the other places in the cluster, and then target port 8080. So here I'm targeting the container, this server container running on port 8080. Now, for the purpose of this demo, we're using this type called node port. This could be load balancer or anything like this, but what this is going to do is create a port mapping on all of the nodes in the cluster so you can talk to this container. So given that Kubernetes is running in a virtual machine, this will allow us to expose it to outside the cluster. So I can say kubectl create -f. I need to go to the right directory. Now I can say kubectl get services, and I can see that, all right, I have one service called demo. This is the cluster IP, this is the private IP. Now if I say kubectl describe service demo, I see here is my node port. So what I need to do now is find the IP for the node in my Minikube cluster. So I can say Minikube IP. Take this IP, pipe this to curl. Let's get the right port here. And I get the counter. Now, if we wanted to, we could just watch this. And we can see the counter is working. So this is a brief demo of what you can do with Kubernetes. We haven't covered deployments or rolling deploys or anything like that. This is just the first step, and there's plenty of much better material than this for how to get started with Kubernetes. I think there's actually another webinar from Cloud Academy on specifically Kubernetes, but there's plenty of great information out there on how to get started with Kubernetes and what it can do. So let's switch back over to the presentation for the wrap-up. So I've put together one more poll to help me prepare for part 3. So part 3 is the final entry in the series, and what I'm hoping to do there is more of a open Q&A to get as many questions answered. So please answer this poll and help me get prepared for part 3. So, great. Thank you everybody for taking the time to answer the poll. That is, let's see, yes, that is all I had for the presentation and demo. So now I'll go through the submitted questions, try to answer as many as I can in the time remaining. So let's see what we have here. Okay. So first question is, which tools are you using for this demo? Yes, it's a good question. It was my mistake not to introduce everything, but I am using Docker Compose and some custom programs I wrote for this, the polar, the counter, and things like this. Minikube to run Kubernetes locally, and yeah, actually, that's it. So here's a question. Are we constrained to use AWS offering Docker services if we use AWS services? The answer is no. You can run, say, you can choose to use ECS, or you can build your own Kubernetes cluster on top of ACS. You can even run Mesos or Empire. You don't have to use anything specific to you have more options than just the AWS offered service. Okay. Here's a question. After Docker for AWS and Azure go public, wouldn't that make Kubernetes much less desirable? I can get a swarm just by clicking a button, and I still use JSON to configure everything. The answer is I don't necessarily think so, because each of these tools is suited to different use cases. One of the reasons why I recommend it in Kubernetes is because it fits really well for container native applications, and it has more different functionality than, say, Docker UCP. So yes, you will probably end up using JSON or some configuration files for everything, but regardless of whatever option you go for, you can get a hosted version, so it's not necessarily just Swarm. Okay, one question. What would you use for service discovery with Kubernetes? You can use their built-in DNS add-on, or when you create services, you will have environment variables accessible in each container in a pod to locate other services. Another question about Kubernetes. Are the containers created in one host or distributed? So this is, so pods themselves are constrained to a single node in the machine, given that, or constrained to a single node in the cluster, given that those containers are supposed to be communicating. So the answer is that they are hopefully running on the same node. Question here, is the pod.yaml the Kubernetes version of Docker compose.yml? And the answer is kind of. They include different sorts of information. The pod.yaml only contains the information for the containers and how to run them. But what's included in Docker Compose is also, say, some dependencies, ports to expose, and networking. This is sort of where the service file I showed comes into play. Would you recommend, here's the question, would you recommend running a hybrid Docker environment, for instance, running dev on my local machine, but DB and app hosted on Docker. I'm not quite sure exactly what that what the gist behind that question is, but I think that if you are considering deploying on Docker, the effort to create a local Docker environment is quite trivial, even if you're on Windows or OS X. That the need for a hybrid model is not really there. So if you can, I would suggest installing Docker on your local machine and using that for your development process so that you get more experience with working with containers and all the things you can do with them, and in turn that will actually improve your production infrastructure and your production deployments. Go to the top here. I would love to, here's the question. I would love to learn how to manage and monitor Docker containers. Okay, so when it comes to monitoring and getting information, there's many different ways many different things you can use to manage and work with these different containers. So you can say run something like Ditdog, and that will integrate with your Docker host and can push metrics about your containers upstream. You can use something like CA Advisor, Sysdig, pretty much any type of monitoring tool, any type of metrics collection tool or monitoring tool is going to have some sort of integration for Docker containers. And what this usually boils down to is running something on the Docker host that will connect to the Docker daemon and then push metrics upstream. We have time for one more question. Okay. Have you tried running Docker with Jenkins, Git, and Bitbucket for CI and CD? The answer is sort of. Well, I have not used that exact combination, specifically Jenkins and Bitbucket. I have used Docker all the way from development up into production, even on CI. Regardless of whatever type of CI system you use, be it like Jenkins or like any of these host services, as long as you're using Docker throughout the process, it don't really matter. So, and you can also use Docker to, say, compile your jars or your wars or your bins or any of these artifacts. So you can definitely use Docker containers throughout your pipeline, all the way from, you could say, run your tests in a particular container, throw that away. If your application is not containerized, and you can use that to kick off all sorts of stuff. So the answer to that question is yes, it's definitely possible, regardless of whatever combination of tools that you're using, and I recommend that you do give it a go. So I think that's all we have time for today. There's plenty of other questions for me to answer, which I will answer in the Cloud Academy community forum. You can check the Cloud Academy webinars page for more webinars. There's webinars are happening all of the time. If you're interested, I suggest you check out the webinar on Kubernetes. And if you have the time and are interested, you can join for part 3, which will happen in about a month from now. So thank you everyone who has stuck around. I hope you learned something, and good luck out there, and happy shipping.